Scientific notation. This video will help you understand scientific notation, write large numbers in scientific notation, write small numbers in scientific notation, and write numbers in scientific notation in standard decimal form. Understanding scientific notation. Very large and very small numbers are often tedious to write. Since these types of numbers come up in many situations, especially science, a shorthand way to write them was devised. So let's take a look at a couple very big, a very big number, which is our national debt. Then we'll take a look at a very small number, which is the mass of a proton. So if we look at this national debt here, looks like 17,100,000,000,000. So writing a number that large has a lot of zeros, and a lot of times it's hard to kind of keep track of those zeros. And it takes up a lot of space. So what we've done, if we write that number in scientific notation, here's a very condensed or shorthand way to write that. In scientific notation, that number would simply be 1.71 times 10 to the 11th power. Now let's take a look at this mass of a proton. This is a tiny, tiny, tiny little bit of weight, and that should be grams, by the way. So that's a tiny little bit of weight there. And so to write all those zeros, or even to keep track of all those zeros, could be very tedious. But if we write this in scientific notation, look, it's very simple. It's 1.65 times 10 to the negative 24th power. Let's look at a definition now of scientific notation. A positive number is written in scientific notation when it is expressed in the following form. So notice we have some number, a, and we're going to multiply that then times some power of 10. So our n there is an integer. Some power of 10, and our a now has to be between the numbers 1 and 10, and we're not going to include 10 in that value. So notice it's strictly smaller than 10. So anywhere between 1 and getting as close as we can to 10 without actually reaching it can be the number a. So notice our examples here. The first example was this national debt, 1.71 times 10 to the 11th power. And then let's take a look at our other example here, 1.65 times 10 to the negative 24th power. Notice if we're going to represent a large number, our exponent on the 10 is positive, in this case positive 11. If we're going to represent a very small number, notice our exponent on the 10 now is negative, and that will always be the case. The other thing to note here is that since a has to be between 1 and 10, we always have one digit in front of the decimal. Notice 1.65 in this case, and over here 1.71. Now that digit doesn't always have to be the number 1, but it does always have to be a single digit in front or to the left of the decimal. Now it may surprise you to know that our number system is base 10 because we have 10 fingers. Every time we count 10 digits in a place value, we have essentially used up all of our fingers, and it's time to move on to the next place value. So I've kind of written 3 of our place values here, the ones, tens, and the hundreds place. So to get from the ones place to the tens place, we are going to count 10 digits. Once we've counted those 10 digits, we use all our fingers up, so then we jump to the next place value. That's why our number system is base 10. Now, every time we jump a place value, we are essentially multiplying by 10 to jump. It takes 10 of these ones to make a 10, and it takes 10 of these tens to make 100. So when we multiply by a power of 10, it's as simple as moving the decimal to the right. Let's take a look now at some powers of 10 here. I have 10 to the first power, which would just be 10. Now if I multiply by 10 to the first power, notice what happens. I've taken this number, I just made this number up here, 2.51, and I'm going to multiply that by 10. Now we could go through and do some long computation or even punch this into our calculator, but there's no need to. When I multiply by 10, all that's going to do is move our decimal one place to the right, and I get this answer of 25.1. Notice, power of 10, the power of 10 there was the first power, we moved the decimal one place. Let's take a look now at a power of 10, that's the second power. 10 to the second power is 100. When we multiply by 100, I'm going to move the decimal 2 places. So again, I'm taking this number 2.51, multiplying it by 100. All I have to do is simply move the decimal 2 places to the right to get this answer of 251. Now let's look at 10 to the third power. That's 1,000. And as you might guess, 10 to the third power, we're going to move the decimal 3 places to the right. So if I take 2.51, multiply by 1,000, move the decimal 3 places to the right, I get this answer of 2,510. To create a shorthand version of a large number, we move the decimal and multiply by a power of 10. For example, let's say I was going the other way around now. I'm starting with this number that's in standard notation here, 2,510. Let's say I wanted to write this in scientific notation. Well, I would need to have just one digit to the left of the decimal, which is right here, the 2. Then I would want to put the decimal. Now I want to take this 2.51 and I want to make sure that it's equal to this 2,510. So I'm going to multiply by a power of 10 to do that. Well, to make this number 2.51 equal this one over here on the left, I need to move the decimal, notice, 1, 2, 3 places to kind of get back to that number. So I make sure then that I multiply by 10 to the third power. Now let's take a look at some examples that will help you understand how to write large numbers in scientific notation. Example 1, we're asked to write this number 2,000 and write it in scientific notation. Well, if I'm going to write this in scientific notation, I need to have one digit to the left of the decimal. So it's going to be 2 point, in this case, the next digit is 0, so it's got to be 2.0. Now I need to multiply by a power of 10 so that this 2.0 times this power of 10 is going to equal 2,000. I don't want to change the value of 2,000 here. I just want to write it in this scientific notation. So let's see. If I was trying to get 2 to kind of go back to become 2,000, notice I would have to move this decimal 1, 2, 3 places to the right. Well, 3 places to the right means I need to multiply here by 10 to the third power. Okay, example 2. I'm asked to write this large number in scientific notation. Well, let's see. So I'd say, okay, 3.45. I know I need to start there because I need one digit to the left of the decimal. Now I'm going to multiply by some power of 10 to make sure this is equal to the original number. Well, let's see. To get this decimal back in the original plus spot, I would have to move this decimal now 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So to move that decimal 9 places, I'll multiply by 10 to the 9th power. Question 3. Again, this huge number, we want to write this thing in scientific notation. So I'd say, okay, 1.2 times 10 to some power. What power? Well, let's just move the decimal. I'm starting here at kind of 1.2, which is right here. And I would need to move that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. So 10 to the 13th power. Now it's time to check your understanding of writing a number in scientific notation, a large number in scientific notation. Go ahead and pause your video player now and write each of these practice problems in scientific notation. When you're done, hit play to see how you did. Okay, practice problem 1, 500. We want to write this in scientific notation. So we'd say, okay, well, we need 5.0. So we need 5.0 times 10 to some power. Let's see, if I want 5.0 to become 500, I'd need to move the decimal 1, 2 places. So times 10 to the second. Question 2. Well, I got 7.5. Let's see how many places I would have to move that decimal in 7.5. So if it started right here, I need to move it 1, 2, 3, 4, 5, 6, 7, 8. 8 places. So 10 to the 8th power. Question 3. 2.0. Looks like we're going to need to move this decimal a lot of places. Let's go ahead and count it out. We're starting the decimal right here in 2.0, and we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 10 to the 15th. Now I went ahead and I moved that decimal to the right, counting one at a time, but we could actually do a little bit better than that. These digits are all grouped in groups of 3, so I could have just gone, 3, 6, 9, 12, 15. Writing small numbers in scientific notation. Before we start rewriting very small numbers in scientific notation, we need to remember 2 concepts. The first one is that we can write any division problem using a reciprocal and multiplication. So remember when we had fractions here, and let's say I was doing this division problem, 1/2 divided by 2/3. Instead of doing that division, what we did is we changed it to multiplication. Remember, we would take the reciprocal of the second number, which was 3/2, and then we would turn it to multiplication. So any division problem can be rewritten as multiplication as long as we use the reciprocal. The second concept is that a negative exponent gives us a reciprocal. So for example here, if I have 10 to the negative second power, that actually, when I turn it into a positive exponent, is 1 over 10 to the second power. Now that we've got these two concepts, we're ready to go ahead and take a look at writing small numbers in scientific notation. When we divide by a power of 10, it simply moves the decimal to the left. Remember, multiplication moved the decimal to the right, so division is going to do the inverse of that, move it to the left. Let's take a look here. So if I had 10 to the first power, which is just 10, and I took the number 251 here, and if I divide that number by 10, all it's going to do is simply move the decimal now to the left to make this a smaller number, right? If we divide by 10, we're obviously going to get a smaller number. So remember, in 251, the decimal starts out here on the right side. Dividing by 10, all that's going to do is move the decimal one place to the left, and we get this 25.1. Now notice what happens if I divide by 10 to the second power, or 100. Again, I'll take 251 now, divide by 100. That's going to move the decimal 2 places to the left. So I start it here, move it 2 places to the left, and I get this answer of 2.51. Now, it would be really easy to understand scientific notation if it were written with division. However, computation is a lot easier if we write all of the scientific notation as multiplication. And since we're going to rewrite this as multiplication, we're going to have to use negative exponents to get a reciprocal. So let's take a look at what that looks like now in scientific notation. So instead of dividing by 10, what we're going to do is we're going to multiply by this 10 to the negative first power. And remember, all that's going to do is give us a reciprocal of 1/10. Now, if I took, again, the same number I did before, 251, and now I multiply by 10 to the negative first power, what this really is going to look like is this. It's going to be 251 over 1. 10 to the negative first power is really 1 over 10. So essentially, I'm doing the same thing I did before here by multiplying by a negative exponent. I'm taking 251 and dividing by 10, which is going to move that decimal one place to the left. And notice, I get exactly the same answer I did before when I did the division. So instead of dividing by powers of 10, what we actually do with scientific notation is we multiply by a negative exponent here. Let's take a look at this next one. Multiplying by 10 to the negative second power is really the same as dividing by 100, which is going to move our decimal 2 places to the left and give us this answer of 2.51. Once you kind of understand this, it's pretty easy then to make these decimal movements. Notice 10 to the negative first power means we're just going to make this number smaller by moving the decimal one place to the left. 10 to the negative second power means we're going to make this number again smaller by moving the decimal 2 places to the left. Now let's take a look at some examples that will help you understand how to write small numbers in scientific notation. Example 4. Well, we're starting out with this small number here. We want to write this thing in scientific notation. Well, to be in scientific notation, we need it to have one digit to the left of the decimal. So it really needs to be 1.2 times some power of 10. Notice now we're going to take this 1.2, which is a larger number, and end up with this smaller number, 0.00012. So we're going to need to multiply by a negative power here to make 1.2 a smaller number. So I know that's going to be a negative power because I want to make this a smaller number. 10 to the what negative power? Well, we just need to count the decimal. So I'm starting the decimal right here, and we're going to move it 1, 2, 3, 4 places. So 10 to the negative fourth to get that, to write that in scientific notation. Okay? Example 5. Starting with this small number, I know that I have to have one digit to the left, so 3.47 times 10. Well, I'm starting with 3.47. I need to end up with this tiny little number up here. So again, I know I have to have a negative exponent. And I just count this out to figure it out. So we're going to move that decimal 1, 2, 3, 4, 5, 6 places. So 10 to the negative sixth. All right, let's see. Question 6, example 6 here. We're going to have 8.0 times 10. And again, a negative exponent. We're going to end up with a real small number here in the end. So let's see. We're moving this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 places to get it in that spot. So I'd have to multiply by 8 times 10 to the negative ninth. Now it's time to check your understanding of writing small numbers in scientific notation. Go ahead and pause your video player and answer these practice questions. When you're done, hit play to see how you did. All right, question 4. Well, we want to write this small number in scientific notation, so we'd say, okay, 9.13. We're going to make this number considerably smaller, so I know I have to multiply by a negative exponent. 1, 2, 3, 4, 5 spots. So 10 to the negative 5th. Practice question 5. Well, we need it to be in this form here, 2.56. Well, we're not going to have to multiply by 10 to very big power. All I got to do to get this to become 2.56 is just move it one place. So that would be to the negative first power. Question 6. All right, to get it in scientific notation, we need it to be 4.16 times 10 to the, well, we're going to make this 4.16 a much smaller number. So I better multiply by a negative exponent there. 1, 2, 3, 4, 5, 6, 7 spots. So 10 to the negative 7th. So up until this point, we've taken a lot of numbers that are written in standard decimal notation and then gone ahead and rewritten them in scientific notation. Now we need to reverse that. Let's take numbers that are written in scientific notation and write them as their standard decimal equivalents. So go ahead and pause your video player now and write each of these scientific notation numbers in standard decimal notation. When you're done, hit play to see how you did. All right, let's take a look at question 7. 4.1 times 10 to the negative 6th. Well, we need to write this now in standard notation. So let's see. We're going to take this 4.1. Now I'm multiplying by 10 to the negative 6, which means I'm going to end up with a much smaller number than 4.1 when I'm done. So I'm moving this digit or this decimal 6 places now to the left to make this a smaller number. So let's see, I'd move 1, 2, 3, 4, 5, 6. There's where my decimal is going to be. Now I'm just going to fill in my zeros. So it looks like 5 zeros in front of that 41 to get our answer there. All right, let's take a look now. Next one I have here is the 6.12. So 6.12. I'm multiplying by 10 to the 5th power. Well, multiplying by 10 to the 5th is going to make this a much bigger number. So I need to move this decimal to the right. And I need to move it to the right 5 places. So let's see, 1, 2, 3, 4, 5. So that has me adding some zeros there. Now let's go ahead and write these digits down and put the commas in. Okay, so it looks like 612,000 there when I write that in standard decimal notation. All right, question 9. 2.136. I'm multiplying by 10 to the 9th. That's going to make this number larger, so I need to move this decimal to the right to make this number larger. I need to move it 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my decimal. I'll add my zeros in. All right, now let's rewrite all these digits and put our commas in. 3, 6. I need 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros. Put my commas in. So it looks like 2,136,000,000 for our answer there in standard decimal notation. So we're just going to practice this again, only if you need it. If you nailed those last 3 questions and you've got writing a scientific notation number in standard form, you can disregard this part of the video. But if you need some more practice, go ahead and pause your video player now and write each of these numbers written in scientific notation in standard decimal notation. All right, practice problem 10. Starting with 7.1, I'm multiplying by 10 to the 6th. That's going to make this a bigger number. So I'm moving this decimal now to the right 6 places. 1, 2, 3, 4, 5, 6. Add my zeros. All right, let's write down the digits here. Looks like 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Put my commas in. So it looks like 7,100,000. Question 11, I'm taking this 5.12. Now I'm multiplying by 10 to the negative 5th. When I multiply by 10 to the negative 5th, I'm essentially dividing by 10 5 times, which is going to make this number a lot smaller. So I need to move this decimal to the left 5 places. So 1, 2, 3, 4, 5. There's my decimal. Let's add the zeros in. All right, let's see. So 0.0, 4 zeros. 1, 2, 3, 4, and 5, 1, 2. Question 12, 2.1. Again, I'm multiplying by a negative exponent here, 10 to the negative 7th. That's making this number smaller. So I'm moving this decimal to the left 7 places. 1, 2, 3, 4, 5, 6, 7. There's my decimal. Add my zeros. So 1, 2, 3, 4, 5, 6 zeros. 4, 6 zeros, 2, 1.